already are moving on from quadratic trinomials. And today we're starting with quadratic functions or quadratic equations. Okay? So writing utensils down and just pay attention. I'm going to do a quick intro just so that we get our brain wrapped around what quadratic functions are and where we've seen them. Okay? Here we go. Lights, please. So, thank you. So I'm pretty sure you've seen this before. Look up. Okay. Now this is a more modern type of theater, but check this out. Look up. But one of the things that I want to point out is that the curvature of the theater. Do you guys see that? Yeah. So check this out. This curves, and the seating all across everywhere is curving. Now that's done for a purpose. Now let me take you back to the medieval times or Roman Empire times. I'm pretty sure you've seen pictures of the Colosseum, the Roman Colosseum. It's circular, right? They use the same idea in regards to quadratic functions. They saw that if you start at a certain point here, and you have sound coming out projected everywhere, and you have this function throughout the entire seating, the sound will have high quality. That's why back then they didn't have speakers. They had persons standing in front of people and speaking, and the sound was projected all the way out. Does that make sense? And once again, this is an application of quadratic functions. Also, you've seen also in movies in medieval times where the king is sitting at his throne. There's people either standing or sitting at a table. Well, guess what? The back wall where he's sitting was curved. Why? Because when it's curved, he can hear everything that's coming his way. And let me show you how that works. Watch. Here's another application. You guys seen these, right? So how this works, it works like this. Check this out. Up in space, we have satellites. Satellites send repeated signals. So signals that are repeating and they're going towards Earth. Well, somehow those signals need to be picked up. Those signals are picked up by dishes. Back in the 70s, they used to call these parabolic antennas. And they get that from the graph that it creates a quadratic function called a parabola. Now check this out. Why does this work? Let me show you. When signal comes in from outer space, it hits the dish anywhere. But since it's curved, it bounces and it sends it to the center of that dish. That's why right above it, or right here, is what we call a receiver. All the signal is received in that, and that creates data, and that's how we get our cell phones to work, and so on and so forth. That's pretty cool, huh? Also, you've probably seen these. They're starting to come out with these at Walmart, Costco, and such. They're starting to curve the TVs. Who's seen that? Because they're trying to use the same idea in regards to function. They're saying, if this curves and they sit it in a living room or in a den or a TV room, whatever, anyone that's seated around the projection in regards to visual, it's also projecting and it could be high quality. Okay? Now, the last application that I'm going to show you, there's more, but let me show you the last one, is the one that probably we never think about because we're always having fun. Quadratic functions. You guys ready for the ride? Okay, here we go. Ready? Whoa! is curved. You see it? That's one. All right, I'll stop right. What? Oh. Where? Oh yeah, I see it. All right, so look up, please. Look up. So, some of the designs in roller coaster. I know it involves also physics and other science and mathematics combined, but a lot of this has its base with curvature. And if you notice this curve right here, this is a parabola. Also, this is a parabola, also known as quadratic functions. Today, we're going to be using stuff like that in order for us to graph and solve quadratic functions. Does that make sense? Have you guys seen that before?
Yeah.
Yeah, right? And now it makes sense. You're like, oh, now I can picture it, but we really never thought about a roller coaster. Does that make sense? All right, so, lights, please. With that said, open up your packet to the Cornell note that I included in there. I know. Our objective for today, I can solve a quadratic function by graphing. Let's read together. 1, 2, 3. I can solve a quadratic function by graphing. Copy that, please, at the bottom left. I see some of you looking, instead of looking at the objective, you're looking at the spider. Mm-hmm. I see Nina like writing and she's looking up like, oh my goodness. All right, here we go. So, look up. Everyone, what is our concept? What is our concept? Quadratic function. So, from this point forward, if you notice, we usually left the summary for maybe special occasions when I gave you some more notes, or for something else in regards to fill it in. But from this point forward, you're going to have to start coming up with an essential question that is addressed in the lesson. For example, here's an essential question. In the summary part of your Cornell notes at the bottom, where it says summary, write this question down. What is the solution to a quadratic function? What is the solution to a quadratic function? What is the solution to a quadratic function? And we'll address that. Oh, thank you. Oh, thank you. So we'll answer that question after we go over some examples to see if you can actually extract that from the lesson. Everybody got it? All right. Also, let's fill out our Ferrier model. Quadratic function. A function in y form in which the highest power of the variable is 2. A function in y form in which the highest power of the variable is 2. Examples. Write this down. F of x equals 2x squared, and y equals 2x squared. According to the definition, it says a function in y form which the highest power of the variable is 2. Question, is this the same as this? Yes, the only thing this is called what? Tell your neighbor, what is this called? Bless you.
Linear function.
No. It's not a linear function. This is function notation. Yes. Yeah, we have, I know, that's what I'm saying, I'm trying to get us there. This is function notation, which is the same thing as the variable y. Everybody with me? Let me show you some more examples of the quadratic function. Y equals x squared plus 2, and y equals x squared plus 5x plus 6. All those are examples of a quadratic function. Let me show you a non-example. So according to the definition, a quadratic function is a function in y form where the highest power of the variable is 2. Okay, do we have that here? Yes. Y form? Yes. Okay, non-examples. Y equals mx plus b, y equals x cubed plus 9, and x squared plus 5x plus 6. As you're writing those down, start comparing. If these are quadratic functions, why are these not? And you're thinking that to yourself, these are not because, talk it over with your neighbor, why are these not quadratic functions?
No, but that doesn't matter.
Okay, let's see. According to the definition, these are quadratic functions. These are not. So, why is this one not a quadratic function? Go ahead, Charlie.
It doesn't have any constants.
If we were to substitute this with a constant, it would have. Okay, so let me replace this with a constant. There it is. Now that it does, why is that not a quadratic function? She's got it. What's that? Okay, let me change this.
Okay, now I don't know.
Okay. Who can elaborate on this one? Hallie. Why is this not a quadratic function?
Wait, you have me?
No.
No. There's no wrong answer. Wrong answer.
There's no wrong answer. Go. Okay. Liv, help her out.
Well, because the power of the variable is not true.
The power of the variable is not 2. It has to be 2.
But it doesn't have to have, a power of 2.
Remember when we covered quadratic trinomials or quadratic whatevers, what was the exponent on a quadratic? 2. Okay.
But it has to be there.
It has to be there. This one does not have it, that's why it's not that. Okay? Let's go to this one. Why is this one not a quadratic function? Christine? Because it's cubed. So what is the name of this one, Christine? If this is a quadratic function, what is this one? Cubic function. That is correct. And you should have seen these in 7th grade. They should have introduced this one. Be nice. And the last one. Why is this not a quadratic function? Go ahead, Francesca.
It's not in Y form.
Be nice. It's what?
It's not in Y form.
In other words, elaborate a little bit more.
It's not in. It's not an equation.
It's not an equation. What is it?
An expression.
This is an expression, and these are what? Equations. Very good. Let's come up with some hashtags. Liv, go.
Hashtag power of
Power of 2. Hannah.
equation.
Equations. Good, Noel. Why? Why what?
Why?
Why? All right, that's fine.
Why?
Why? Francesca.
Hashtag quadratic.
Hashtag quadratic. Okay, I'll take those. All right, and that's enough. All right, so steps. Here goes your steps. Bam! Yeah, bam! So, to get us started, turn your Cornell note over. In the back part of the third model, you should have 3 coordinate planes, yes?
Yeah.
Okay, let's get started. On the top left, write this down. Example 1, solve by graphing. This is going to go pretty fast, so I need you guys to stay focused, okay? Example 1, solve by graphing. Write y equals x squared. So, now let's think a little bit outside the box. This is where I had some people having trouble today. I don't know why. They're asking us to graph. Let's graph first and then we'll solve. They're asking us to graph. And they give us this equation. What can we do? Talk it over to your neighbor. What can we do? Talk it over to your neighbor. Neighbor.
The y-intercept is 0, 1, so then, can't you put the 1, line 1? Yeah, so it's 1, so it's 1 over 1 x squared. So 1 over 10.
Okay. So let's see. Philip, what can we do to graph this? What did your neighbor say? Cassandra. Yeah. Lisa. Use a y-intercept, but that's only 1 point. We need a lot of points. What can we do? Talk it over to your neighbor. What else can we do? You need to come up with something. By now, you should be able to do that. We need a lot of points, not just 1 point or 2 points. Alright, let's see. Gio.
Out of 1?
Close. Noel, you got it.
Make a table.
That is correct. Make a table. X, Y. Therefore, what domain do we use for our table, everyone? -2, -1, 0, 1, 2. And that's why the very first time that we graph, I said, anytime you need to graph and you don't know what else to do, any other method, what is the easiest one? Use a table. Yes. Here we go. Yeah, even if they give you funky stuff, guys, like this, y equals 1 over x squared minus 6 x plus 7, or whatever the case, and you don't know what to do, how to graph it, guess what? Use a table. You know what I'm saying? Yes, Mr. Q. All right, so with that said, look up. Let's write this. Y equals, and instead of x, open a paren, squared. So what is our first value? -2. If we substitute -2 there, what is -2 squared? 4. Okay. Next value, -1 squared. 1, 0 squared. 1 squared. 2 squared. 4. Okay, let's plot those. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. So, here we go. Shh, focus. I'm going to sketch this. Pay attention. I'm going to sketch it. Pay attention. Look up. Just for the purpose of those of us that are artistically challenged, I'm gonna go from left. Pay attention. We always go from left to right because that's how we read, and that's how we read mathematics the same way. We go to the farthest point to the left, and then we start sketching our curve. So here we go. Look up. The farthest point is this one, yes? So I'm gonna make my curve go through there, through here, start curving, come back up, through there, and there's my parabola.
Parabola?
Parabola, yeah, that's what it's called. It's a quadratic function, but the name of the graph is known as a parabola. That's why in the 70s, those antennas, they used to call them parabolic antennas. Bam! So, here goes the next part. For this next part, look up, bless you. I need you guys to focus. I'm going to show you how to solve a quadratic function using the graph, but I'm not going to say anything. You're not going to say anything. Let people think. Then we're going to do 2 more examples and see if your rule works. Everybody understand? Don't say anything so like that you don't trip people up in regards to their thinking. Here it goes. Look up. I'm going to show you how to find the solution. Write that down. Okay? All right. Example 2. Copy this one on the next one down. You have space. Example 2, y equals negative x squared. Y equals negative x squared. And once again, everyone, how can we graph this one? Table. Bam. Negative 2, negative 1, 0, 1, 2. And let's rewrite this. Y equals, make sure you mark well the negative so you can see it. Open the parentheses for the variable and a 2. And the reason I'm telling you this because many times on the part A, some of you mark the negative very lightly and then you start making mistakes with your computation. Does that make sense? Yes. All right, here we go. What's our first value, everyone? Negative 2. So what is negative 2 squared? 4, but what's outside of the paren? So this becomes negative 4. That is correct. Next value, negative 1. What is negative 1 squared? 1, and what's outside? Negative. So this is negative 1. How about 0 squared? 0. How about 1 squared? 1. And that is negative 1. 2 squared? 4. And that's a negative 4. Let's plot that. Negative 2, negative 4. Negative 1, negative 1. 0, 0. 1, negative 1. And 2, negative 4. And once again, we go to the farthest point to the left, and it starts sketching our parabola. So we start down here. We're going to go through all these points and start curving it. Once again, those of you that are artistically challenged, go slow. Slowly, go through that, curve it, and arrows at the end. And what is this called? A parabola, yes? Yes. All right, and let me show you again how to find the solution. So far, so good? Yes. Okay, so you should have in your noodle maybe a rule starting to appear in regards to how to find the solution to a quadratic function. This next example, example number 3, is going to start clarifying a little bit more. Okay? Here we go. Example 3. Copy this. The bottom left. Y equals x squared plus 2x. Let's make a table. You guys like my table? The table? Get it? My table? Never mind. X, Y. Some of you are like, what? Negative 1, 0, 1, 2. All right. Let's rewrite this. Y equals parentheses squared plus 2 times parentheses. All right. Now that you know what we're doing, see if you can fill out the table by yourself. Ready? Go. I'll give you some time for that. Go. Let's see. Nina, when x is negative 2, what is y? 0. Hands if you got that. That is correct. If you don't see it, negative 2 squared is 4. What is 2 times negative 2? Negative 4. Negative 4 and 4 is 0. That is correct. Next value. When x is negative 1. Hannah, what'd you get?
3. Wait, no. 1? Negative 1.
Negative 1. Hands, have you got that? That is correct. Everyone, when it's 0. 0. Gio, when it's 1. 3. And Brian, when it's 2. 8. Let's plot those. We got negative 2, 0. Negative 1, negative 1. 0, 0. 1, 3. And 2, 8. Once again, those of you that are artistically challenged, go slow from left to right. Slowly, go through each point, curve it, and arrows at the end. Now that we have a parabola, let me show you the solution to these and see if it confirms what you were thinking as to how to find the solution. Here it goes. Solutions. Negative 2, 0, 0, 0. Talk it over with your neighbor and let them know what is the solution to a quadratic function. No. For right now, because of the examples, yes, but once we get, yeah. All right? So now, I think you already have the rule, but you still have doubts in regards to one of the solutions, right? You might have a little bit of doubts. Let's clarify it. Behind the warm-up sheet, you should have 3 more graph papers, right? Yes, Mr. Q. All right. Copy this one. Example 4. Oh, sorry. Let's go a little bit faster so we can get this done. X, Y, negative 2, negative 1, 0, 1, 2. All right? So Y equals parentheses squared minus 2 times parentheses. First value is negative 2. What is negative 2 squared?
4.
4. What is negative 2 times negative 2? 4, so this is 8. Next value, negative 1. What is negative 1 squared? 1. What is negative 2 times negative 1? 2, so this is 3. 0. 1 squared? 1. What is 1 times negative 2? So this is negative 1. What is 2 squared? 4. What is 2 times negative 2? Negative 4, and that is 0. Let's plot those points. Negative 2, 8. Negative 1, 3. 0, 0. 1, negative 1. And 2, 0. Our parabola. All right. Solutions. Who can give me the solutions for this one? Charlotte?
0, 0, and 2.
0, 0, 2, 0. Hands if you agree with that. All right. So think about the question that we wrote on our summary. The solution to a quadratic function is, it's not always going to be 0, 0, because we need to get to another one. Who can start filling us in? A solution to a quadratic function is? Close. Hannah?
Is on the x-axis.
On the x-axis, where what? Who can elaborate some more? on the x-axis where what? No. Let me go back to the other one so you can see them. Where what? Francesca. Okay. Where, let me help you a little bit. Where the graph, what? Live, go. Intersects what? Close. The x-axis. Let's see. Does this graph intersect the x-axis? Yes, are those 2 points? Those are my solutions. Let me go to the previous one. This one. Previous one. This one. Previous one. This one. But some of you are still not clear in regards to this point. Is that correct? Yeah.
We can't be on the x-axis where the parabola and intersects with the x-axis.
Yeah. Yeah, that's fine. Open up your iPad. Let's go to Desmos. And we're going to graph the last two on Desmos so we can see what the solutions are for those. So go to the last page on your packet that looks like this. And you should have the last two that you're going to graph on Desmos, yes? Does everybody see that in there? Somewhere? Okay. So, everybody went to Desmos.com? Desmos.com. Let's graph the fifth function. What's the fifth one, Jasmine? Read it to us. Y equals? Okay, hold on. X. To write the square on your Desmos, you go to the one that says a squared. Y equals x squared plus 3x, you said? Yes. And what else? Plus 2. No, it's plus. It looks as a minus over here, but it's 3. Get the left light, please, Maya. Thank you. Do you see it? It's on your paper? You guys have the paper? It's positive. On mine it says positive here. Alright, tell your neighbor the solution to that function. What are the solutions to that function? Does that confirm our definition? Yeah. Yeah, our answer, right? Whenever the function intersects the x-axis. Are we there? Yeah.
What is the description of
We'll get to that. Give me a second. Erase this one. Let's go to the next one. Read me the next one, Jasmine, please. Y equals what? X squared. Plus 1x minus 2. Tell your neighbor the solution to that function. Okay. So leave that one there. Look up. But I want you to pay attention. Look up, please, really quick, so that we can fill out the description. Hold on. Let me go back to this one. Description for this last one. Look at this one. So this one's a little bit different from the rest, yes? Okay. Let's go to the graph. These are the solutions, this one and this one. Do you agree with that? But do you notice another intercept?
Yeah.
And look at this function. Are we there? You're like, I kinda see it. Okay, let's type in the previous function. Y equals x squared plus 3x. And what was the last part? Plus 2? Plus 2. Look at the solutions, but look at the other intersect. And look at this function. Talk about your neighbor. What do you see? What do you see in these two? Be nice. Who sees it? You do? Nina, can you elaborate, please, in regards to the last part of each function? What is that called? A little bit louder. The y-intercept. Let's see. -2 is on this one. Where did it cross? -2. This one is +2. Where did it cross? +2. Everybody see that? All right, so what I want you to do at home with this page, I want you to go to Desmos, and I want you to start by typing this one in. You're going to type it in. Describe it. Oh, this one opens up, and it's at the point of origin, whatever the case. Then underneath, you're going to type this one in and see what it does. Then from there, you go to this one compared to the first one and see what it does. Then you're going to type this one in compared to the previous one and see what it does, and so on and so forth. Everybody understand?
Yeah.
I know. So, your home play for tonight is the 2 play sheets that are in the packet. Only. There is tutoring today. If I don't see you, have a good one. Enjoy your home play. See you guys tomorrow.
This is our home play
Bye.
right here. This one and this one.
Yeah.